This tutorial is to help prepare you for the quiz over loops, which is Chapter 5. This is the second part of this tutorial. So the next thing I'd like to talk about in this tutorial is what a running total is. Well, a running total is where you add an amount which may not be fixed. It is not constant every time. If you look at an incrementer, we're adding 1 every time. That's fixed. If you look at a counter, we're adding 1, we're maybe adding 2, we're adding, whatever, but it's always a fixed amount. A running total, you're adding something every time, but it may not be fixed. Here's an example of that. Let's make a bank account program. So I could say that I'm going to go for 4 months and I want to see how much money I can deposit in my bank account over the period of 4 months. So I'll say int I is equal to 0. If I'm going 4 months, I'm going to say I is less than 4. Now, I do 4 things, starting at 0, counting up 2, but not including 4 because I do 0, 1, 2, 3. That gives me the 4 things. So often in computer science, we start at 0 and we always go 1 less than what we're looking for. It's just a convention we use here. I could have just as easily have said start at 1 and we're going to go I is less than or equal to. The main reason people don't use that is a little bit later we're going to start to study arrays, and with arrays always our first available index is at 0, so it's a little healthier to get used to this convention now, so you won't be so surprised when you see it later. So I'm going to say I++, we're just going to count up. Of course, now we know we have another way of writing this. I could say ++I, just to be different. Now, inside of here, I'm going to ask cout, enter the amount of your deposit this month. And if you're living from paycheck to paycheck, you know that probably varies quite a bit. So I'm going to declare some variables here. I will declare double amount. That'll allow me to even enter cents if I want to, and double total. Now, obviously, if you have some amount in the bank, when you first start off, it's going to start off at 0, so it's very important you initialize whatever that value is. So this is going to allow me to enter 4 months worth of deposits into my bank account. And when I get finished with this, I want to output what my total is. For this to work, what I need to do is I need to take input on whatever that amount is, and then I need to add that amount to whatever my previous total was. So I'm going to say total is equal to whatever it was last month plus that latest amount you're adding in. And this line right here, it can be written many different ways. You can use all kinds of different variables for this, but if you say some variable is equal to itself plus some other variable, this is a running total. Don't get fixed in on what the name of the variable is. We don't care if it's I, we don't care if it's T, we don't care if it actually says total. That doesn't matter. No matter what, when I look at an equation where I have a variable equal to itself plus some other variable, that will be a running total. And it's one of the most important expressions we have in all of computer science when it comes to doing code. So at this point, I think this program is going to work. Let's see if our running total works. Now, before we do it, let's just make up some values. Let's say that the first month I'm able to deposit $10, the second month I'm able to deposit $20, third month I'm able to deposit $30, and the fourth month I'm able to deposit $40. If I add up all the money I've just put in the bank, how much money do I have in the bank? Well, let's see. 10 and 20 is 30. 30 and 30 is 60. 60 and 40 is 100. I have just deposited $100 in the bank. Well, let's go ahead and run the program and see if we actually have our program produce that value. So what I'm doing is I'm really doing a desk check here. I'm checking to see if my program works. So what is enter the amount of deposit this month? First month, it's going to be $10. Next month, it's going to be 20. Month after that, it's going to be 30. And the final month, I'm going to deposit 40. There we go. I have $100 in the bank. You can see this running total works. So there's a nice example of what a running total is. Now, it can also be called an accumulator. Same thing. Accumulator, running total, same thing. We have different kinds of loops that we need to be aware of. Some loops are conditional loops. That's a loop that repeats the processing of data while a specific condition is true. So what I have with my while loops earlier is a conditional loop. And actually, even with my for loop here, I see a condition here, so this too is a conditional loop. Both of these are conditional loops that I just pointed out. Now, they do mention here this term side effect. And it says a change in the value of the variable as a result of carrying out an operation. You see a beautiful example here of a side effect. I was changing what the variable amount was here. So amount first is 10, and then 20, and then 30, and then 40. And what it has effect on is the total. So the total variable here was equal to 10. In my next step, the total variable jumped up to 30. After that, it became equal to 60. And after that, when I added on 40, it went to 100. Well, here, total was my one of my variables. It is a side effect. It's a change in value of a variable as a result of carrying out an operation. So you can see these are side effects. What was happening to total was side effects. Even, to some extent, the loop control variables, as they change, as I changes here, those are side effects too. So all of these things are changed within the loop, each pass of the loop. So anytime you have a variable changing in any way as it goes to its new value, that's called the side effect. Okay, a little bit lower, I've got this business of IO_manip, and it is using to format and to list examples. And I give an example here. I'm going to go ahead and copy this line of code, and I'll paste it into my program here. To use this, I need to include a header file we don't see too often, which is called IO_manip. And what IO_manip is used to do is usually to format our output in some way. So I'm going to give a little example of this. I'm going to paste this code here, and we'll see what setW1510 endl does. Now obviously I'm going to output 10, but what does setW15 mean? And if you think about it, or if you've done your reading already, you probably already have a pretty good idea. Let me go ahead and rebuild this, and I'll run it. It appears I have an error in my code. Let's find out why. Oh, I've got a console window open down below. Let me try rebuilding it. And let's run it. And I'm going to enter some values in here. And here is the effect of setW15. What did setW do? Well, if you count the number of spaces to where that 10 begins, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, that 0 shows up at the 15. So what is it doing? It moves something over to the right, and there is some left justification to it. You move it over a little bit. So if you want to jump things over, if you want to set up columns that line up nice, this is a great way of doing it. Let me show you an example of this. So I say setW15. Let's do another setW here. I'll say setW15 of 1.234, and then an endl. Let me copy that line. I'll paste this down again. Let's change up these lines a little bit. I'll say that I have a 5 here, something a little bit different in size than the 15. I'll put 200 here. I'll do it one more time. I'll make this 132, and I'll make this 1. What happens when we do this? Well, you're going to see, in essence, what I've just done is I have made a table where everything is going to line up nicely to the right. There you go. Oops. Excuse me, I need to enter a few values before I say there I go. And now you can see how everything lines up on the right. You see that? So I've got 15 spaces over to the right edge of this number and 15 spaces over to the right edge of this number. This is now going to allow you to make very professional looking tables within C++. So set W is a great command to know about. So if you've got some financial columns or some data like that you want to take care of, this is just a great thing to know. Let's read a little bit more about this. It right justifies the number. Here's another thing that we can do. You have already seen this in some of your programs. This is also done with set W. So if I hit return and I output this, let me make my screen wide enough that you can actually see what's going on. From here on out until I change things, I'm going to show a decimal point, and I am going to see 2 places behind the decimal. This is perfect for outputting money. So if I say double, my money is equal to $345 and 0.6789 cents, which is crazy, but you start to see things like that occasionally at the gas pump where you're paying 0.9 cent, or you may run into that in interest, and of course you're always going to get a rounded amount. Now let's go ahead and output my money. Now you are going to get this formatted automatically for you because you've asked for it here. And if I say start without debugging, let's just fill in some values here. There it is. 2 places behind the decimal. If you put a dollar sign in front of it, it would look just like money. So this is a great thing to use anytime you start dealing with money in your programs. This is not a widely documented line of code. So this is one of these pearls you want to hold on to. You just won't find this on the internet. It doesn't exist. They will talk about set iOS flags and set precision too. It does not do the same thing. It just doesn't. This is the best line of code I've ever seen when it comes to setting up money. And both of these lines, set W, set precision, set iOS flags, fix, show point, all of that, you're able to do because you've declared IOmanip up at the top as a class library. Okay, now down here I talk about what a sentinel is. A sentinel is a data item entered after the actual data item that causes the loop to exit. So a sentinel is what's going to blow you out of the loop. Let's go take a look at a sentinel value. And my program's becoming quite long at this point. I think I'm just going to delete it and let's just start over. So I'm going to declare a sentinel variable. You can call it anything you want. I'll call it double. Actually, I'll call it an integer. It really doesn't matter what. And I'll call it cent for sentinel. You can call it anything you want. X would be a fine sentinel. And now I'm going to do a while loop. And I'll say while cent is not equal to, oh boy, whatever you do, don't punch in a 7. We can't have a 7. If it's equal to 7, boy, we're out of the loop right there. So I'm going to punch in something here that isn't a 7. I'm going to say it's equal to 0 since I have to initialize it. Here's my test condition. Now, we're going to ask the user to input a number. Cout. Enter a number. I'll take that number, whatever they input, and I'll put it into cent, which of course stands for sentinel. And if that number's a 7, we are out of here. Okay? And we've pushed in the sentinel. Let me go ahead and rebuild this. I also need to do a system pause here. So when you see this, you'll just never forget what a sentinel is. I hope. Enter a number. I'm going to enter an 8. Well, 8's not a 7. I'll enter a 3. That's not a 7. I'm going to enter a 1. That's not a 7. Okay, now I'm going to enter a 7. That is the sentinel. That is what's going to blow me out of the loop. Boom, he says, get out of here. And that's what a sentinel does. Everybody understand what a sentinel is? Okay. Now, let's go back to the notes. Next thing I need is a flag-controlled loop. And it says here, a flag-controlled loop is a loop whose repetition condition is type bool variable that is initialized to one value, false or true, and reset to the other value when a specific condition occurs. So in other words, it's kind of similar to a sentinel in that if we hit the true or the false, it knocks us out of the loop, but we're just going to use a Boolean variable here. So let's see how that works. So going in here again, I'm going to declare a Boolean. I'll say bool. I'll call it my flag. And right here, I'll say we're going to do this loop as long as my flag is not equal to false. Typically, that's how you see it. If it's not equal to false, we just keep doing this. Okay. I'm going to get rid of sent here. Now, I'm going to say enter a value 0 or 1. And I'm going to take that and I'm going to put it into my flag. If you put in a 0, you are going to exit the loop right now. Okay? You put in a 1, we're going to continue to do it. Let's go ahead and rebuild this, and we'll see a flag. Now, I just had an issue there, and I even know what the problem is. Why did I get all this gobbledygook? What is wrong? I just violated something I told you never to screw up when you did a loop. What do you need to always do that I didn't do here? What are 3 parts of a loop? Initialize, test, and update. Am I missing something? I never took my flag and set it equal to a value. So let's set it equal to true so that I get into this loop at least once. It had no idea what the value of the loop was, so that was real trouble. Okay, with that, let me close down these console windows and let's give that another try. Now on this upcoming quiz, you really want to pay attention to that. Initialize, update, and test. Okay, I'm going to do a 1. I want to do the loop over. I want to do the 1 and loop again. I'm going to do the loop again. But if I enter a 0, boom, I'm out of there. Now, it's a little bit different than a sentinel because you actually may have some stuff occur in your code that causes something to be false. In other words, let's create a condition. When you hit this, things become false. I'll say if, let's create another variable, int x is equal to 0. I'll say here, x plus equals 1. So we're going up by 1, so you're going to have 0, 1, 2, 3, 4, 5. I'm going to say here, if x hits a number which dares to be greater than 5, I'm going to say my flag is equal to false. There's another nice example of a flag. First time that happens, boom, I'm out of the loop. So let's see this in action. It might be helpful if I output the values of x so that we can see this going on. I think what's going to happen is I'll hit that value of 5. You'll see it displayed to screen, but we're not going to do another loop after that because that's the end of this. We're going to set that equal to false, my flag, and we're not going to run the loop even one more time. And we actually saw 6. Why are we seeing 6? Because when we hit this condition, the first number that's greater than 5 is 6. Do you see that? That's why we output the 6. Of course, you have to be very careful. It's easy to slip up on these things. Okay, I'm going to go ahead and close this program. Let's look at the next thing here. This is a data validation loop, a loop that continues to execute until it reads a valid data item. Michael came up with something like this the other day that was really good. He was trying to make sure that a number was really an integer or something like that. I could do the same thing to make sure that a number is a number. I'm going to declare a char, and I'll call it char x, and I'll declare an int, and I'll call it int y. And I'm going to first make sure that whatever you enter is really truly equal to a number. Now, Michael, was there a trick you used to see if that thing was a number? Were you using... Oh, was it? It was what? Tell you what, let me not deal with this. Let's just make sure that the user enters a number which is greater than 100. We'll say that it is impossible for the user to enter anything which is less than 100. So I'll declare int I. So an example of a data where I want to say that it is a data validation loop, I want something over 100, I could say cout, quote, enter a value for I. Enter a value greater than 100. And now the user knows right away, oh boy, he better put in something greater than 100. Semicolon. Now I'm going to say here, while I is less than 100, opening brace, closing brace, cout error. He's going to get an error message, and I'll say again, enter a value greater than 100. And I'll put a little indel on the end of it. Actually, maybe I better put a colon here, a couple spaces, and then I'll take input on I again. And they're not going to get past this until they enter a value greater than 100. First time we enter a value here which is greater than 100, and I guess if it's really truly greater than 100, I can't include 100, so it's got to be like 101 and be the first number you input. I take that, and then I can have a little message at the end, quote, congratulations, you entered a number greater than 100. Now where this is really used is a lot of times if you enter data, you're checking it first to make sure it's numerical data as opposed to letters or weird characters. So this would be what you'd use it for, but for what we've got right now, we don't know about that stuff yet. That will be coming up in the next chapter. Let's go ahead and rebuild this. Also, let's run it. And I've got a bug. Oh, I never initialized the value of I. I guess I'm going to have to initialize it to something greater than 100. Let me go ahead and rebuild this. And now when I run this, it says, congratulations, you entered a number greater than 100. I didn't meet the condition right away. Let's enter a number which is less than so that we get into the loop the first time. That was sort of a dumb thing to do. Let's go ahead and run it. Error, enter a value greater than 100. You know what? Maybe we don't want to have that message in the beginning. Let's just get rid of our error message here. Now, If I try it now, enter a value greater than 100. If I enter a 1, nope. Enter a 2, nope. Enter a 3, that's not greater than 100. But if I enter 101, congratulations, you entered a number greater than 100. So here's an example, a simple example of a data validation loop. At this point, this concludes the tutorial.